Hello, geometry students. Today we are going to learn a new process that would allow us to do the following, which is to look at a right triangle. We're still working with right triangles and right triangle trigonometry, but maybe I should just kind of describe, what do we already know how to do? Well, if we have a right triangle like this one, like number one, right? We we know how, and we've got one side and we got one angle. We learned how to find another side, which basically means we can find all the sides. Of course, if we got one of the angles, we can also figure out the third angle because remember, it's a right triangle. We always have one of the 90 automatically if we're doing right triangle trigonometry. So, but again, what we learned last time is you give me one side of a right triangle and give me one of the non 90-degree angles, and you should be able to solve for x if you can. Now, what are we doing today? Well, we're going to take a jump, we're going to level up, and we're going to try to find another skill, which is kind of in a sense going in reverse. So if you look at this triangle here, number 4, and you'll notice that it's a right triangle, of course, but instead of getting an angle, we've got a question mark for an angle we're trying to figure out. But instead of having one side, now we have two sides. So that's what we're going to learn how to do today. In a sense, we're going in reverse. Instead of having one side and one angle, to then get the second side, we're going to have two sides and try to figure out, well, what angle was it that would allow us to get one of the other sides? Okay. But first, what you should do to review, what you already know, is go ahead and do problems 1 through 3. And I will go ahead, I'm not going to go through each one. I'm going to go ahead and provide the solutions once you're done, so you can go ahead and just see them and see the steps. And then, of course, if you don't understand, you can ask me. Now, you should have done the lesson last time, which showed you detailed steps in a video on how to do it. If you haven't done the last lesson that showed you how to find the side of a right triangle, if you have one side and one angle, then please do that now. You'll need to go through that lesson, okay? Like I said, go ahead and pause this video, try problems 1 through 3, and then come back and I'll show you the solution. Of course, check with your table mates to see what they're getting as well. Okay, so here's the solution for number 1. Again, always remember, write down SOHCAHTOA. Number 2, always label your sides. Number 3, figure out what side you're given and what side you're looking for and determine that's H and A or adjacent. So you need A and H, that would be cosine. So I did cosine 27, the reference angle x over 13, and then I did the algebra. All right, so now I'll put the solution for number 2 next after you try it. Okay, so here's number 2. Check that out. Okay, and here is the solution for number 3. Okay, so again, this is something that ideally you're getting pretty comfortable with and you know how to do. So now what we're going to do is we're going to jump to the lesson for the day. So if we know two sides of a right triangle, we should be able to figure out all the angles. So I'm going to show you something here real quick. The relationship between what we know and what we're going to learn about. Okay, I'm going to show you a site here that's got a great breakdown of it. Again, this is the generic right triangle, right? The hypotenuse is opposite the right angle. Opposite depends on the reference angle. So that's the reference angle, that's the opposite, and the remainder is the adjacent. We also know that sine takes an angle and gives it this ratio here, right? So that would be sine, or S, equals O over H, as in SOHCAHTOA. Now the inverse sine or function is designated as sine -1, and it takes the ratio of the sides, the opposite, over the hypotenuse, and it gives us an angle. So again, this diagram kind of shows the relationship. So what we've been doing and what we did today in the reviews, we had an angle, right? And we were able to figure out the opposite and the hypotenuse sides, or at least we had one of them and we were able to figure out the other one if we knew the angle and we used the sine function. Today, we're going to have the two sides given, but not know what the angle is, but we're going to use that ratio to go back and then calculate the angle. So it's basically going in reverse, okay? Okay, so let's go ahead and think about what we already know. So we know the regular ones, it's sine theta, right? Or the angle. So let me go draw a little triangle. Maybe draw a triangle like that. And we've got, for example, we got theta, right? Over here. And then this would be opposite. This would be hypotenuse, and this would be adjacent, right? So we know that sine of the angle is equal to opposite side over hypotenuse, right? Okay. Well, the difference is for the inverse, and I should have made this so in your notes, maybe make a little title here. So the inverse is going to be sine, and I'll put -1. Now, when I write it, a lot of times I'll just put to the power of -1. So that's like sine to the power of -1, it looks like. And then in parentheses, it's going to be opposite over hypotenuse. You can just write h. Now that is equal to theta. So again, it's kind of flipped. Instead of it being taking an angle and then getting to the sides, or at least one of the sides, now we're going to start with the sides and we're going to get to the angle. See how that works? So what are the other ones? So now you know that, go back to my black ink. Then we've got cosine. And again, I'm just going to make that c to the -1 is going to be what? Same thing, a over a, right? So it's going to be adjacent over hypotenuse, sides is equal to theta, the theta angle. And then finally, tangent, -1 is TOA, right? So opposite over adjacent is equal to theta, okay? So it's just basically flipping the angle and the sides and then putting it to the -1, okay? Now, why do we do this? Because what we're going to figure out how to do today is, without having an angle or angles other than the 90-degree, right? We know that it's a right triangle. We'll start with two sides, and we're going to use those sides and the ratio of those sides to figure out one of the angles. But first, we need to figure out the calculator steps and how to use inverse sine, like this right here, this example. So like, for example, if you look at the example over here, maybe the way to think about this one, okay, maybe the way to think about this example here is that you got to remember 9/20 represents sides of a right triangle, right? So you're going to have, one's going to be, if it's sine, it's going to be O over H, right? So this would be like the hypotenuse, and this would be like the opposite, right? So that would mean, let's say, we're trying to find whatever angle that is. That opposite would be over here, hypotenuse would be over here. So we're basically trying to figure out that angle. And this is the process. So what you do is you use your calculator. You're going to go sine -1. Well, I'm going to pull up the calculator and show you the difference. Normally sine, we hit this, right? I'll clear this out. We hit sine and then put in an angle, right? But I don't know if you've got a calculator, you should be able to see it here. And make sure you're going through these steps with your calculator, please, so you can see how to do it. See how it says on top of sine, it's sine -1? Well, you got to hit second and then sine -1. And then what you're going to do is you're going to put in the ratio of the sides, right? So we've already done this on a calculator. Then we're going to put ratio of the sides. So if we do 9/20, we're going to do 9. And it's important that fraction is division, divided by 20, okay? So it's got to be 9 divided by 20, and then you hit enter. Where's my enter? There he goes. And then you get 26.74, which is what we should get. Of course, we're rounding it to the nearest whole number, so 26.674 or whatever, that would round to 27, okay? So that's how we got, how you get 27. So why don't you take a moment to use your calculator and do the cosine of the, this is okay. It says it's got the angle symbol, but that's the same as finding the angle. Same here. We're trying to find an angle that would give us a ratio for tangent ratio of 5/3. So I'll do one more with you. So we're going to do the cosine. Again, remember the ratio is 1/5, right? We're trying to find an angle that, when we do cosine, would give us a ratio of 1/5. So I'm going to go to my calculator, and now I'm going to go second cosine, 1 divided by 5, parenthesis, equal, and that should be 78.4. So you can round it to 78. So that's how you do that. So go ahead and try the next 78 degrees. You guys try these two, pause me, and then come back and see what you get, okay? Okay, I did tan negative 1, 5 over 3 from up here, right? And I ended up getting 59 degrees. Now I'm going to do sine negative 1, 12 over 13. Let's see what we get there. So second sine 12 divided by 13, enter, and I get 67 for this one, okay? All right, so that's how you do it. Now what we're going to do is we're going to see if we've got these two sides here, let's focus on finding x, okay? Let's focus on finding x. What would allow us to figure out x? So step number one, we did what we do before. We're going to label. Since we're trying to find x, we're going to label sides. This would be opposite. This would be the hypotenuse, and this would be adjacent. Okay, so we're doing that same process. Now what we're going to do is we're going to figure out which we should use. Well, we need to use the sides that we have. So that's going to be A and H. So what has A and H is going to be Ka, right? So Kato, you should have that up there somewhere. So now what we're going to do is we're going to go not cosine, but cosine negative 1, inverse cosine. And instead of putting the angle, we're going to go A over H. So what's our A? It's the 5 over the 15. And that's going to equal our theta, in this case, the x degrees, right? So we're going to get our calculator out. And we're going to go cosine, inverse cosine, which is going to be, again, second cosine, and then we're going to go 5 divided by 15, parenthesis, enter, and we get 70.5, which rounds to 71 degrees. So there you go. So that means that that's equal to 71 degrees, this angle over here. Now, okay, so now you're ready to try out your new learned skill about figuring out, so I'll go to question number 4, figuring out what is the angle down here based upon having two sides over here. Okay, maybe what I'll do is I'll let you try it first. I've already labeled the sides and I've already written SOHCAHTOA. So you guys go ahead, you finish it off and then pause me and then check with your table mate and then come back to see if you got it. But see if you can finish this up and then I'll have the explanation when you get back. Okay, well, what do we have? Well, first, when we're doing this, we look at, well, what sides do we have? Here we have 31 and 21, which is the opposite and the hypotenuse. So we need O and H, which is going to be the sine, right? So we're going to go sine negative 1, and then the opposite. Again, maybe I should be writing this out, the generic sine negative 1 opposite over hypotenuse. That's not a bad habit to get into. So what is it? So 21, and then after that, write the 21. So 21 over 31, what does that equal to? Okay, again, we get our calculator, again, sine 21 over 31. So we go, but again, second sine 21 divided by 31, parenthesis, enter, and we get 42.6. Where are you, problem? 42.6. Now here you're going to have to do some rounding, okay, to the nearest integer. So 42.6 is going to be 43. So just round to the nearest whole number. But that's pretty much how you do it, guys. That's the step you need to go through. So go ahead and finish the rest of them. Let me check your answers before you enter it into Canvas. And let me know if you have any other questions after that. Great job. A and H, cosine, right? So now we're going to do cosine negative 1. A over H, right? Okay, I think my computer just crashed.